Welcome back to Networking Fundamentals by Yamaha Commercial Audio Systems. I'm Pat Kalani. In prior videos, we covered the fundamentals of IP communication, but we were largely focused on the local area network. In this video, we'll turn our attention to the router. We'll differentiate between some often confused terms, such as the router, the gateway, the firewall, and network address translation. With those concepts under our belt, we'll walk through the mechanics of a few remote access methods, including the DMZ, port forwarding, and VPN. So we know the router is our bridge from the local area network to the outside world. Now, the outside world could be the internet, or it could be another network that's under our control. When we need to reach a device outside our network, we make a request to the gateway. Remember, it's like calling the operator. Operator assistance, how may I place your call? On a network diagram, a router is represented as a very simple device. However, when I log into my router, I see an awful lot of settings for something this simple, right? Well, the diagram at the right might better demonstrate the typical home or SMB hardware router. It usually also includes a small network switch, Wi-Fi capabilities, a DHCP server, DNS relay, and maybe even VPN services. Now, to put this in perspective, let's draw an analogy to something from our industry, the digital mixer. When mixers were analog, we associated mixers with head amps, busing, and matrixing. In separate racks, we had graphic EQs, effect processors for reverb and delay, and dynamic processors. All of that was outboard. As Yamaha was pioneering the world of digital mixing, the engineers realized there was a real benefit to taking some of these outboard processors and wrapping them right inside the digital mixing platform. Among other things, it reduced latency, it simplified the clocking setup, and it brought the power of recall automation to devices that didn't always have it before. So now, let's apply that to the world of networking. Hardware router manufacturers can achieve a similar synergistic effect by wrapping multiple network management tools into the hardware router platform. Besides the fact that you don't have to cobble together multiple boxes, many of these services will require many of the same settings. By logging into the hardware router, you make the setting once, and it automatically propagates those values across all the services that need it. And that's a huge time saver. Features like NAT translation, DMZ, and port forwarding really are core routing features. However, DHCP servers, DNS assistance, and VPN remote login really are separate functions that have been wrapped into the router over time. Let's start by clarifying the difference between some often confused terms, such as the gateway, the firewall, and network address translation. If you remember, when we want to access a device that's not on our local area network, we don't just contact it directly, right? When we want to contact a device that is not on our local area network, we contact the gateway, which then takes our request and completes the call outside the network. You might remember my analogy from earlier. When we contact the router, it's like calling operator assistance, and the router picks up. Operator assistance, how may I complete your call? The router takes our request, picks up a separate phone line, and completes the connection for us. Anything it gets from one handset, it repeats in the other, and vice versa. So the router is always in the middle of your communication. We're clear on that. Well, now let's point out that the router can keep track of multiple conversations at the same time. Here we have a computer talking to one server, and the phone is contacting another. So in this sense, you could think of the router not as a single operator, but as a call center full of operators, each one of which can work on a separate request. Now, this idea of receiving connections on one network and completing them on the other, that's the idea of network address translation. And without overcomplicating the explanation, let's just say that's how the router keeps track of a number of inbound connections and a number of outbound connections to make sure that data always gets where it needs to go. Now that brings us to this concept of the firewall. Essentially, the firewall is this idea that you can make connections to the outside world, but people from the outside can't get in. Now you might remember in an earlier video, I said that the arrowheads on these lines are significant, right? It represents who is contacting who. this is a point where it starts to matter. You'll notice we can make a connection out on the internet because we call the router. The router says, oh, I've received a connection on my local area network. I'm going to complete it out on the internet. And when data comes back on that line, the router knows, oh, this is a call I placed. It uses network address translation to get data back to the original requester on the local area network, and all is good. However, when the router receives a connection from the wide area network, it says, what do I do with this? Let me look at my instructions. Now, when some people think of the firewall, they think of an involved, active process. They envision the router somehow bobbing and weaving and sparring with devices that are trying to get into your network, right? The reality is it's much more simple and much more passive. When the router receives a connection from the wide area network, the router says, now what instructions do I have when I receive a connection on the wide area network? Well, by default, there won't be any. So the router just hangs up that phone. That's it. Pretty effective, right? Now, if you wanted to allow remote access to devices on your network, that's when you would put instructions in that list. And that's when we start using things like the DMZ, port forwarding, and VPN. So let's take a look at that now. The easiest remote access method to understand is the DMZ. DMZ stands for the Demilitarized Zone. Put simply, it instructs the router to forward any incoming connections from the outside world to a particular device on your network. Effectively, if somebody contacts your router from the wide area network, all they're going to see is that device in the DMZ. Now, while it's nice that you could remotely reach this device in the DMZ, so could anybody else. Remember, the router is taking any incoming requests from the wide area network and sending them to the device in the DMZ. There's no login credentials or security provisions whatsoever. So, if you put a device in the DMZ, be sure that you're happy with the security provisions that it has. Now, similar in concept to the DMZ is a feature called port forwarding. So the most important thing in port forwarding is to understand, what is a port? Let's suppose we have a network device that will run multiple applications. In this case, we'll use an example of an email server and a web server running on the same device. When the email client and web browser want to log in, they're both contacting the same server. So how does the server know whether the connecting device wants to check email or browse the web? The answer is that an IP connection consists not only of an IP address, but a numeric flag called a port number. In our example, we're using port 25 for the email server and port 80 for the web server. There is a standards body that establishes default values for many common protocols, but if you're in control of both ends of the communication, you could really use any port number you wanted. In fact, some IT professionals might intentionally scramble the port number for sensitive services just to confuse anybody that's trying to hack the network. When the server receives a connection from these devices, it can figure out which application to connect these requests to just by looking at the port number on the request. Now, whether you know it or not, you're using ports every time you go to a website. Let's suppose you want to go to Yamaha.com. Well, the web browser probably won't make you type Yamaha.com:80 because 80 is the default value for web servers. In fact, once the web browser takes you there, it'll probably hide the :80. Now, if you typed Yamaha.com:81, or any other number for that matter, the server hosting our website won't feed you to the web server application anymore. And so your web browser will probably show an error. In the address bar, the port number you've called out will remain with the URL so that you can see what port number you're trying to access. Now, how do we put this into practice? Well, when the router receives a connection from the outside world, the router can choose which device to send it to based on the port number. Now, there are some similarities between port forwarding and the DMZ. In both of these cases, there's no security provisions for the devices you're forwarding requests to. Again, the router is trying to be as transparent as possible in this exchange, so any security will have to be provided by the target devices. The difference between the two is that the DMZ forwards all requests to a selected device on the local area network, whereas port forwarding will only forward requests on specific port numbers. So, you could route different services to different devices on your network if you choose, and if you receive a connection for a port that hasn't been designated, that connection will just be blocked. So why do we go through the DMZ and port forwarding? Well, two reasons. The first one is my opinion, but by going through that exercise, I think it furthers your mechanical understanding of the firewall. Now, secondly, if your audio network is to join a property network, the DMZ and port forwarding may come into play. Let me give you an example. So here we have a simple diagram of the property network, right? We have the router separating the property network from the internet. Well, now let's add an audio network to this mix. The wide area network port on your router could be a member of the property network. Realistically, this will provide some protections from the audio network polluting the property network or vice versa. The devices on each level of this network really don't have any reason to interact with each other, so keeping them on separate layers is a practical thing. Now, if you were to gain favor with the IT professional running that property network, they might take the router for your network and put it in the DMZ of their network. That would allow you to run a VPN application, which would give you remote access to your audio network from anywhere on the internet. Okay, so I mentioned VPN, right? So what is that? VPN stands for Virtual Private Network. You know it as the work from home remote login. Effectively, you can take this laptop that's on the network and take it out of the building, go anywhere in the world, and remotely log into your network. The laptop connects to the router, and the router forwards you to an application that creates a secure tunnel between your laptop and the router. Now, of course, the VPN server is going to require some kind of security credentials. Maybe it's a username and password or a pre-shared key. But once you're past that hurdle, the VPN server will relay information from your laptop, making it feel like the laptop is on that local network. Now, in the diagram, I represented this as a ghost roaming the network with your laptop, right? You're really someplace else, but it looks as if you're on that network. Now, the real practical application for VPN is remote tech support. Let's suppose the person operating this sound system runs into a problem. Well, they're going to call the lead tech for the facility or perhaps the dealer that installed the system. The person receiving that tech support call normally has to say, what does this screen say? What is this LED doing? And so on. If they could remotely log in, they could use CL Editor to look at that console. They could use MTX Editor to look at the DSP processor, and so on. So that would speed up the tech support process, and in the event that you had to show up on site, you might have a better idea what you need to show up with. Well, that about wraps up part one on the router. We pointed out that most hardware routers will host multiple network management tools, not all of which are core routing functions. We differentiated between commonly confused terms, such as the router, the gateway, the firewall, and network address translation. Finally, we introduced the basic tools of remote access, including DMZ, port forwarding, and VPN. Thank you for joining us, and I welcome you to check out our next video on DNS.